Hello students, this is Anjali Diwalkar. It is very much known to you that we have started our equilibrium portion. In that we are going to deal today with the space force. Which are the space force actually? In the first chapter itself, we have learned about space forces. If the forces are not in the same plane or they are not a coplanar, they are non-coplanar, then those kind of forces are being called as a space forces. System of forces lying in a different planes forming a three-dimensional force system. Such system is called as a space force system. Okay. As forces have three dimensions, we have to use vector approach. Here, we'll learn to represent a force vectorially. To find vectorally moment of force about a line, to find magnitude and direction of force given in vector form, and another basic concept we are going to with the basic operations we are going to learn over here. First of all, try to understand what is a space force. As I told you previously also, in the first chapter we have learned about coplanar force system. If all the forces are lying in the same plane, then they are a coplanar. If few forces are in a one plane and another few forces are lying in another plane or a different plane, then those kind of force system is being called as a non-coplanar force system, which is roughly being called as a space force. Force in a vector form. How is it is being going to denote it? See, X, Y, Z, three planes are there. In that, a force F is being acting from A to B. Okay. Coordinates of A are x1, y1, z1. Coordinates of B are x2, y2, z2. Force in a vector form is being denoted as a force. F is equal to unit vector is equal to F into EAB. Okay. It is also unit vector. Then F is equal to F force means vector force is equal to F into EAB unit vector. How we are going to work out farther end minus nearer end, that is x2 minus x1, y2 minus y1, z2 minus z1. For x2 minus x1, it is very much known to you in a vector form. We used to write down along with it I, y2 minus y1 j, z2 minus z1 k, divided by x2 minus x1 square plus y2 minus y1 square plus z2 minus z1 square. Please do remember this formula. Roughly we can write x2 minus x1 divided by under root x2 minus x1 square plus y2 minus y1 square plus z2 minus z1 square is nothing but fx. Likewise, y2 minus y1 divided by under root x2 minus x1 square plus y2 minus y1 square plus z2 minus z1 square is nothing but fy. Fz is z2 minus z1 divided by this complete value. Okay. Fz into K. See, this is a standard formula. We'll solve one MCQ. A force of magnitude 650 Newton passes from P to Q. Values of P are 0, 3 and 0. Means x1 is 0 and z1 is 0, y1 is 3. Likewise, Q's coordinates are 5, 0, 4. Put this force in a vector form. What is formula with us? F is equal to F simple force into unit vector of PQ. Okay. Value of F is given to us, that is a 650. X2 minus X1. Here X2 is PQ word is there. For that reason Q's coordinate will be X2, the second one, and P's will be first one or starting one. So 5 minus 0, okay, then y2 is 0, 0 minus 3, then z2 is 4, 4 minus 0. So 5 minus 0 will give me positive 5, then 0 minus 3 will give me negative 3, and 4 minus 0 will give me positive 4. I take it accordingly, divided by x2 minus x1 square is 5 square, then negative 3 square is again 9, positive 9, 4 square is positive 1. So if we operate it or if we solve it, we'll get 4596I, no, 4596I, 275.76J, 367.68K. So from that, fx is nothing but a coefficient of I is fx. In this equation, we know coefficient of I is fx, right? So 459.6 is fx, 275.7, don't forget to mention a sign, negative 275.76 is fy, 367.68 is fz. Okay, that was the question being asked. What they want, put it in a vector form. Okay, so find out fx, fy and fz. Then magnitude and direction of force. How we are going to work out the magnitude and direction of force? Force F is Fxi plus Fyj and Fzk. Okay, so it is being denoted like this. Inclination with x-axis. This is theta y. This is theta x actually. Very sorry, and this is theta z. Okay. Here, Fx is a component of force in x direction. Fy is a component of Fy and Fz are the components of y in a y and z direction. Magnitude of force will be given to us by using this formula under summation Fx square plus summation Fy square and summation Fz square. Likewise, if force is in a two dimension, then summation Fx plus summation Fy will be our resultant. Likewise, okay. If we refer to the last problem, we can find out F by using above formula. Okay. Also, fx is equal to, this is also again another formula, fx is equal to f cos theta x. Theta x, very sorry, this will be theta x and this will be theta y. Theta cos theta x, cos theta y and cos theta z likewise. Fx is f cos theta x, fy is f cos theta y, fz is f cos theta z. Theta x, theta y, theta z, force directions, value of which lies between 0 to 180 degree. Please do remember, it's a cup of tea for you. You are supposed to mug up. Okay, you are supposed to mug up these equations. There is an important identity which relates them. That is, as we are having in two dimension cos theta x, cos square theta x, cos square theta plus cos square theta x plus cos square theta y is equal to 1. Likewise, cos square theta x plus cos square theta y plus cos square theta z is equal to 1. Determine the magnitude and directions of forces. F is equal to 345 I, 150 J and 290 K. See, this is again one mark question. F is equal to fx square plus fy square plus fz square. Directly you can know the coefficient of I is nothing but fx, coefficient of j is fz, fy and coefficient of k is fz. We can put that value, we can find the value of f. Magnitude of f is 475 then. Fx is equal to f cos theta x. Cos theta x values is not known to us. So cos theta x is equal to fx by f. Fx is 345. Okay, coefficient of y. And f we have just now worked out, that's 475. Then if we take a cos inverse of it, we'll come to know theta x is 43.42. Likewise, fy is equal to f cos theta y. From that we can find out value of theta y. By equating fz is equal to f cos theta z, we can find out happily theta z. Okay, this completes your problem. Then moment of force about the point. This is a very important operation while dealing with the forces. For coplanar force system, m is equal to f into d. In a space force system, moment requires vector approach. Here, F is a force in a space. Okay, see, here we can see F is a force in a space. Means it is some portion is lying in a xz plane and one portion, a few portion is lying in a xy plane. Okay, then let C be the point. Sorry, here F is a force in a space passing through points A and B on its line of action. Okay, A is having x, y, z different coordinate and B is also having some x2, y2, z2 coordinates. Okay, let's see x3, y3, z3 be the moment center. Here C we are taking a moment. Okay, which we are going to find out. Okay, there are few steps which are to be followed. Force in vector format. First of all, find out the force in vector format, that is fxi, fxy, fyj and fzk. Sometimes it may be given to you. Find the position vector existing from the moment center to any point on the force r. R is the distance. Okay, then rxi, ryj and rzk will be, see, this is a position vector. Ca is a position vector. Okay, Perform the cross product of the position vectors and force vector to get the moment vector. M is equal to R cross multiplied with F. Okay. Then we can find it out with using this matrix IJK, Rx, Ry, Rz, Fx, Fy, Fz. We are supposed to put the value over there. Okay. We'll find one, we'll solve one problem. Force of magnitude 80 kilonewton, sorry, 50 kilonewton is acting at a point A, that is 2, 3, 4 meter towards point B, 6, minus 2, minus 3 meter. Find the moment of a given force about point D. D is also given to us, minus 1, 2. So first of all, our first step is to find out force in vector format, that is F is equal to Fxi, Fyj and Fzk. To do that, x2 will use this formula. F values is given to us 50, that x2 minus x1, y2 minus y1 and z2 minus z1. By putting those values, we'll find out what is fx, what is fy, what is fz. Okay. Then you will find out unit vector or position vector as they have asked us to find out. Rxi, Ryj and Rzk. To do that, x1 minus x3 is a to d we are going to deal. Okay. By putting those values, we can find out unit position vector. Are you getting this? A to D we are going. Okay. A to D. What they have given? A is a point from where force has started, as I have marked over here. See, this is our first point, that is A. Instead of C, right now they have given D. A to D we are going. Okay, so this will become x2 and this will become x1. Likewise, so I have solved. Okay, here A to D. A to D I have used and I have worked out Rx, R1 and Rz. Okay, then MD, to work out a moment, we are having this formula. IJK will be as it is, value of Rx, Ry and Rz, whatever we have worked out just now, we'll put those values. Then Fx, Fy and Fz. Then we'll just solve this determinant of it. Then we'll having this equation in terms of I, J and K. Okay. That's it from my side. Thank you very much.